I'm not going to take the time to read the problem since I assume you've already read it and you're checking your answers. Do want to point out that we do have a random sample and we have mode of transportation, sample size, mean wait time and standard deviation of wait time for both samples. Notice it was one sample of 150 patients, but we've divided it into two groups. We want to use a 99% confidence interval to estimate the difference between the mean wait times for ambulance transported patients and self-transported patients. So I am going to use some subscripts to indicate the group. So I'm going to use mu sub s to indicate this, the self-transported people, and mu sub a to represent the ambulance transported people. So here's a couple things that I want you to notice. Make sure that you don't just say mu sub s is the people who drive themselves, because it's not the people who drive themselves. It is the population mean wait time in minutes for people who provide their own transportation. So make sure you do describe it mu as a population mean and what it is a mean of. Okay. Notice also that I didn't take the time to write out the entire context for the second one. I just put ... Okay, so we're assuming the rest of the sentence is the same. Also notice I chose, I want to estimate the difference in the true mean wait times, mu s minus mu a. Notice I did self minus ambulance, and the reason I did that is because self has a larger mean time, so that I'll be dealing with positive numbers instead of negative numbers for my estimated difference in the means, and that's just as easier, so that I just chose that, but you don't have to. I'm actually going to show you what would happen if you didn't choose to do it that way. Alright, so that's how you should define your variables. Now let's take a look at the conditions. The conditions are not different than what you've done before, except for the fact that you're doing them for two samples and you have to do them separately for each sample. And you have to say specifically that the samples are independent of each other. That is really important. They have to be considered. So you can say there were two independent random samples taken and name that. In this case, there weren't two independent random samples taken. There was only one sample taken, but I explain why we can say that the two groups can be considered independent. The reason we have to specifically say this for means is because we have another situation where we have dependent samples, or a matched pairs test, where we do a before and after of the same person, or we have two people that are paired together, two treatment groups that subjects are paired together in a treatment group for an experiment in blocks of size 2, and we have this matched pairs situation where the two samples are not independent of each other, and in that case we have to do a matched pairs t-test, a single t-test of the differences rather than the difference of two means that are independent of each other. Important distinction. Make sure that you say something about that in your planning step. We check that both 73 and 77 are most likely less than 10% of all similar patients in the population, and both are large enough. So we need to check once again, like we did for proportions, that each of the conditions is met for each of the two samples. Okay, now doing your do step. Okay, so remember we have the statistic plus or minus the t-critical value times the standard error of the statistic, and then we do make the confidence interval, and we also need to state our degree of freedom. Now notice here the t-critical value I did not put in specifically, and here is why I did not do that, because the t-critical value is a really unusual number because of the degree of freedom being this weird number. So you are not expected to put that value in for a two-sample t-test or a two-sample t-interval, but you do need to report the degree of freedom that's given to you in the computer printout or the calculator test that you do. So notice I put the 8.3 minus 6.04, which would be 2.26. I put in each of the means, or each of the standard deviations divided by the sample size, so it's standard deviation squared divided by sample size, and the confidence interval. Now, notice here, when I did my key, I made the ambulance-driven, or the self-driven people minus the ambulance-driven people, but I did it the other way around on my calculator just now and showed this to show what it would look like. Notice here that all it would do would make, instead of going from positive 2.29 to positive 4.291, I'd be going from negative 4.29 to negative 0.229. My difference in my x bar diff, which is the difference in these two values, 2.26, would be negative 2.26. But the margin of error and degree of freedom would be exactly the same. I prefer subtracting this direction actually, because it makes it easier to state the conclusion. It makes more sense. But I just wanted to show you what it would look like if you did it the other way around. So here's our conclusion. I'm 99% confident that the interval from 0.229 to 4.291 minutes, notice I put the units here, contains the true difference in mean wait times for people who drive to the hospital and people who take an ambulance when they experience heart attack symptoms. And notice I put self minus ambulance. Whenever you're doing a difference of two means or difference of two proportions, it's really important to make it absolutely clear which direction you are subtracting. Because the difference here indicates that people who drive themselves take longer than people who take an ambulance. And that is actually what we're going to talk about in our next part. What the question asks here, based on this confidence interval, do you think the difference in mean wait times is statistically significant? Yes, because 0 is not included in the interval. If 0 were included in the interval, then we could say that there is plausibly no difference between the mean wait times of the two groups. But since all the differences here are positive, when we subtracted self minus ambulance, we can conclude that there is statistically significant evidence that on average, make sure that you include that in there, because this is not every single person, but on average, people who provide their own transportation have to wait longer in the emergency room than people who arrive by ambulance. So what are some key things that people tend to forget to do in these types of problems? Or in the state step, making sure that you specifically define at the population mean wait time and not just call it people who provide their own transportation. Making sure that you state that the two samples are independent and that you do each condition for each sample separately. Making sure you understand how this formula works and that you can write it down correctly and interpret it correctly, obviously, and when you make sure that you still are talking about the true difference in the mean wait times, not just true difference in wait times. Make sure you use the word mean, because you are talking about averages here, not about individuals. And then when you're talking about statistically significant, make sure that you specifically talk about whether or not 0 is contained in the interval, because when you're talking about a difference, if the difference of 0 is in the interval, there is no statistically significant difference. I think that's it.